Alright, thus far we've been talking about projectiles launched horizontally. Well, now it's time to talk about projectiles that are launched at an angle. Let's say we have a cannon, and the cannon is launching the cannonball at 30 meters per second up at a 40-degree angle. We learned through vectors that this cannonball is being launched horizontally by a vector like that, and vertically by a vector that big simultaneously. If we wanted to figure out what is the horizontal velocity of our cannonball and what is the vertical velocity of our cannonball, we'd use our SOHCAHTOA knowledge, our trigonometry, and we'd say that to find the horizontal part, we'd take the initial velocity times the cosine of our angle, and to find the vertical part of it, we'd take the initial velocity times the sine of our angle. This would essentially become Vy initial, and down here, Vx. Now, here's the thing. I say Vy initial because it doesn't change. Or because Vy initial because this does change. As soon as the cannonball leaves the cannon, that cannonball will begin to accelerate due to gravity downward. That's why I have an initial here. Vx, on the other hand, stays constant, just like we learned before. So if you take that, and you take all of our old equations, and where it said Vy initial, and you substitute this in for that, and then in all of our equations had Vx, and you substitute this in for the Vx, we take all of our equations that we had before, where now we have initial velocity. This would have before said Vi in the y direction times time times, I don't know where my 1/2 went, 1/2 gt squared. That's kind of weird. There should be a 1/2 right there. And then this is going to say, this would have said Viy, and this would have said Viy, and this would have said Vx, because Vx is constant, just like it was before. So that should say 1/2. I'm sorry. Now all of a sudden, we can begin to analyze our projectiles in a much more detailed way. Alright, so first of all, let's do that, and let's grab an arc here. So when we look here, we see that the cannonball is falling away from its path, and almost initially it begins to fall away. So let's say we want to find the maximum height. Things we need to identify here about the maximum height. At the peak of the motion, we can say that the height is at its maximum. We can say that the velocity in the y direction final at the top is equal to 0 meters per second. So with that final velocity y at 0 meters per second right here, we can then grab, where's those equations? They move down, let me grab them here. That changes it. Anywhere where we can say delta y is at the maximum, let's say maybe we want to find the height. You could put 0 in for v final y. You could use the given information here with g, and you could solve for the height. You could find the maximum height of your projectile. You could also, once you have that, you can use this one and figure out the time. Of course, remember there's the 1/2 in there. You could figure out the time of fall there. You could also use this one to find time, because you know that this is a 0, this is a given, you can find time. So all of a sudden, you can start to find things. If you can find the time, you can figure out maybe how far sideways it goes to get there. So really, the equations aren't that much different. It's just that we're taking the initial velocity and breaking it into two parts. We just have to understand a few things about that projectile motion to be able to do this. Now, there's one more equation that you want to jot down, and this one's kind of goofy. It's a combination of two different ones solved and combined. We're combining x's and y's together, but it works. And this is the same equation written two ways. You want to jot this down. Let's say you want to find the range of an object. Let's say they tell you that you hit this golf ball, for an example, and the golf ball is hit with a certain initial velocity at a certain angle. If that's all they tell you, if you use this equation, you can figure out exactly how far it goes, delta x. Or they tell you how far it goes knowing that it was hit at a certain angle, You can find the initial velocity of it. It's a goofy equation. It's huge, but it's really convenient the way it works out. So jot that one down.